So we've looked at multiples, we've looked at prime numbers, we're now going to look at factors. We mentioned factors when we were talking about prime numbers. Kelly May gave us the definition that prime numbers had two factors. We changed that to exactly two factors, but we didn't actually talk about what factors are. Can anybody tell me what factors are? A nice, perhaps, definition of what factors are, Ollie?
Where a number can be divided by its factor to result in a whole number.
That's quite nice. I quite like that. So anything that can divide into a number where the result is a whole number. And that whole number is also a factor. Because we have two factors that multiply to give a number. All right? Sometimes it can be the same one. For instance, if we were looking at the factors of 4, we want all the whole numbers, and I love that part, that multiply to give 4, which are 1, 2, and 4. All right? 1 times 4 is 4, 2 times 2. So we only write that down once. So the whole numbers that can be multiplied by a number, to give a number, are called factors. Example. E.g. factors of 4. Just did that one, so that's easy. So we have 1 and 2 and 4. Now, when we have a large number, we need a technique so that we don't miss any out, because quite often people like to miss out numbers. So if we were doing the factors of 48, that has lots of factors. A good way to do it is what? What do you think would be a good way to make sure we don't miss any out? Emma?
Go through numerical order.
Yeah. If we have some sort of order in our working, we will do okay. All right, so we start 1. 1 goes with, we're going to write it way over here somewhere, 48. All right, the next number that can be multiplied is 2. 2 times 24. Can 3? 3 times 16. Can 4?
Yes.
4 times
12.
12. Can 5?
No.
No. Can 6?
Yes.
6 times 8. Can 7? No. So by doing it like this, we know we've got every single one, so we're not missing any of them out. Okay? So when we want to list factors, that's what it would look like. The next thing we're going to look at is the highest common factor. This is what we call it in New Zealand, but in Britain, they call it our greatest common factor. So we use HCF and they use GCF. Doesn't matter, both are right. All right? They are the same thing. What we're looking for here is the largest number that we can find that divides into the numbers we're given. But it has to be able to divide into both of them. All right? Sometimes that can be 1. So if we were finding the HCF of 8 and 12. All right? What we would do is write down the common factors to find them. So 1, 2, not 3, 4, and 8. 1, 2, 3, 4, 6, and 12. Right? So what is the largest number in both of these? Esther? 4. So 4 is our highest common factor of these two numbers. Sometimes it can be 1. For instance, if you had 2 primes, like 7 and 11, then the 1 and 7, 1 and 11, the highest common factor is 1. All right, so sometimes that can happen. If we have to find the prime factors of a number, we have a method called factor trees. And again, there's lots of descriptions of what factor trees are. They can be prime factor trees, they can be, there's quite a few different ways of asking. They're just asking for the same thing. To do a factor tree, what we do is we actually can divide by any number we like. All right. What we're trying to get to, though, is the only numbers being on there, the only numbers that are left on the factor tree are primes. So let's have a look at 32. So I go, never do 1. We're not interested in the fact that 1 times 32 equals 32. That's not ever in a prime factor tree. We want to go, perhaps, I quite like doing 2s. So 2 times 16. All right, I didn't have to do a 2, could have done a 4, but I'm going to do a 2. You'll end up at the same place no matter what decision you make here. So with 16, I'm going to do 4 times 4. All right. Now, I know 1s, so for 4, I'm going to do 2, and 2, and 2, and 2. These numbers here are all prime numbers. In fact, they're all 2. So when we write the prime factors of 32, we write 32 equals 2 times 2 times 2 times 2 times 2, or equals 2 Esther?
Power of 5.
There are 5 of them. 2 to the power of 5. We can write either of those and they are both correct. Factor trees help us to find highest common factors, but I'm not going to tell you about that today because that's part of our advanced lesson. So you're going to find that out for yourselves.